know it comes. Okay.
Okay.
All right. Thanks, Feroz. Probably, I would also be dropping off in a while, but certainly we'll catch up, right? I'll also catch up with the recordings later, and I will
Okay.
catch up also with you in person on Saturday in the event. Yeah.
Yeah, sure.
Thank you so much. Good luck to all the participants. Thank you, guys. Yeah.
Okay, I think we'll wait for 5 more minutes. Some more people need to join in. Okay.
In the meanwhile, I think there was a question from the participant: when do we really upload the previous recording? Just to let you know, the participants, right? So we will certainly do. We are just doing some usual video editing stuff, right? So that it doesn't really go lagging and all that. So there is a team who is working on. We will shortly be uploading it. So kindly be patient and give us some time. Yeah. Thank you very much.
Meanwhile, if you guys, anyone has any questions from previous last session, then we can discuss that. And then once all participants joins, right, then we can continue from today's session. If anyone has any questions.
Day one, what we suggested, right? The questions can be categorized into two buckets, right? One, based on what Feroz probably explains the concept on a particular day. Others could be a little related, but not necessarily what he would have taught. Again, maybe an interview question, if you are faced, or anything that is related to the topic which you think would be of help, please feel free to be interactive so that all of us can get benefited. That's again just a reminder I wanted to make it to all the participants, right? Okay, thanks, Feroz. I think Feroz and Satish, Souvik, I'll probably take leave. Obviously, my internet bandwidth and stability does not let me continue the seamless flow, right? With all due respect, I leave it to you guys. So to take it over, I'll catch up later. Yeah. Thank you. Have a good evening. Good day.
Thanks, Roger.
Satish or Souvik, let me know when to start.
Yeah, we can start actually.
Okay, sure. Yeah, I think yesterday we were discussing about analysis of algorithm, and then we continued some of the questions on mathematical questions. I think this is the only two topics we covered yesterday, and because of the time restrictions and all. So today I will be continuing arrays, and then we'll see bitwise operators a bit, and then the kind of questions coming from arrays and bitwise operators, and then slowly, if time permits, we'll get into searching and sorting. And then I don't think recursion we can cover today anyway. Yeah, so let's start. So I think I don't want to get into again these things, because already I have covered. Anyone who has not joined yesterday and joining today? Are there any participants who were not there yesterday and they are joining from today itself?
Hi, Feroz. This is Thirumurugan. I didn't join yesterday. I'm joining today.
Okay. Yeah.
Yes, also because of this rain, because I cannot join yesterday. I was joined today only.
Okay, sure. Okay, no issues. Okay, no issues. What I will do, I think you guys won't feel like you guys left out. What I will do is I will briefly cover the chunk of The main thing is like this asymptotic notations basically. So we have three asymptotic notation, big O, omega and theta. Basically, big O is the one which generally represent most of the times, and it will be asked by the interviewers. So it basically used to, represent the order of growth of a particular function, in which order it is growing. So we have two things here. One, what we we usually consider for space as well as time complexity calculations. Nowadays, people are not much interested in finding the space complexity, but they definitely ask you for, time complexity, how much time the algorithm takes. And there are certain factors like to calculation of big O, right? When it becomes how you calculate order of an algorithm, right? So I actually yesterday covered the same thing. Like for example, in this case, the loop is iteration for number of length array. Let's assume that array length is n. So the calculation is like this will take constant amount of time, and even this will take constant amount of time. But this loop will definitely take n number of iterations, right? Because it has to iterate for n number of times. So the calculation here is big O of n, or I can say the growth of this particular function is n, because generally we usually this formula we generally follow. We generally ignore the lower order terms. For example, like 2n square, this is, so so lower order term here is 5n plus 1. For example, like you have a for loop inside another for loop. So, and that is big O of n square, and then you have a for loops 5 times, so that is 5n, and then there is one constant operation. So basically we don't take 5n plus 1 into the account. And then there is second parameter here is we generally ignore the leading constant, like this 2 can be ignored. So it is the order of the growth is big O of n square. So this is the calculation. So when next questions comes, right, I will also try to touch up a couple of things there as well. How you calculate. So let's not get spending much time, because we already 10 minutes our time has been already spent. Okay, then let's start. So there are a couple of questions we covered yesterday, finding a few mathematical things like number of digits in a number, and then we had a factorial of a number, how to check there is a number is prime, printing a prime number, and then checking if the number is palindrome or not. So this kind of questions we can cover. So these slides I will be sharing end of all the sessions, or probably maybe on the Saturday, where we have a common meetup where we will be discussing face to face, and then during that time I will share all the slides. So let's start with our next topic, which is arrays. Okay, so what do you think that arrays is more popular or more famous, right? In terms of basically, I can say two reasons. Okay, one is that not exactly okay. Yeah, I think. Yeah, this one basically, like I have just covered for in terms of Java, actually how you can declare an array. There are two ways you can declare an array, but what I was talking, right, the array has a contiguous memory, right, based on the type of array, right? So that much bytes it will take, and the next element will be after that many bytes. For example, in case of array, right? So for example, let's see, first element is at here. And after length of the data type, right, the next element will be stored. So basically, if you have a base address of this as an array, right? So this is the base address. So the base address plus the number of bytes what an array takes. So you will get a next element. So this and the elements are, like put in a contiguous order. So what benefit you will get when you have a contiguous memory? Basically, you will have the cache friendliness because of that, right? If you get any address, right, you can go to any other address because they are continuous, right? So the cache friendliness comes with that. There is another possibility here is that the random access. based on the base address, you can jump to any ith iteration or any iteration in an array. So that is the random access, correct? So these two things are possible. But what is the, but what is the disadvantages from this? Okay, the disadvantages is that if you don't have contiguous memory, right? You have a memory, but it is not contiguous. So that time you cannot allocate an chunk of array, though you have so much of memory, but you cannot allocate. The cache friendliness also has some problems, right? Any guesses, anyone? What is the problem of the cache friendliness?
Is it something like if you know the address of one element, then simply adding the fixed size so that you will get the next element, something like that?
Yes, that is right. Yeah, that is the advantage as well as disadvantage in terms of like if someone is trying to hack or something, right? And if they know the first memory and they know the type of the array, right? So they can fetch any element. So that is a problem with the cache friendliness. Okay. And what all different types of arrays we have? We have two kinds of arrays. Like one we like fixed size array. In Java, at least we have the array. When we declare array, right, we consider a fixed size array. But there is another data type where we have an array list, which is dynamically growable. But there are different calculations being made. Like when we declare an array list, right, it is not like completely dynamic in nature. Only a set of elements will be defined initially. For example, like maybe 10 elements in an array. And once that like list is getting full, right, again based on how fast it got full, new calculations will be made and the array list will be incremented based on that, right? So these are all different possibilities. And it also behaves the same way, like we still have an address and we can directly jump there. And the advantage in array list is that we no need to have a contiguous memory. Okay, so but still we can address with the base address get set, right? So you can anytime you can fetch with the index. Okay, how you search an element in an array? That's pretty simple, right? You iterate the array and look for a particular element, searching an element. So basically, it is very simple in case of arrays, because it is contiguous memory and like you can fetch ith item anytime. So you will be able to search, right? And if the element is found, so you will return that position of that element, or you will return -1. So I think we already saw this, right? The order of the growth of this particular algorithm is big O of n, because in worst case, it has to go through n number of times. In case, let's assume that the element is not exist in an array, right? So it has to iterate for all the elements and then it has to return -1. So that means it is going to execute all the instructions. So that time it is a big O of n. Let's assume that if the element is found at the 0th location, right, the best possibility is big O of 1, right? And in case, let's assume that element is found in between, right? So that is nothing but big O of, again, same thing, middle one, right? So we still consider it as a big O of n, right? Okay. So you understood, right? Searching an element in an array takes a big O of n type. Okay. How about insertion? So you have an array, right? This particular an array, and you want to insert an element based on the index. So I will give this particular, on this index, you have to insert an element. How will you do that? It is simple, right? So what you do, let's consider this case. So we have an array, we have a length of array, then cap, what is this cap? Okay, this capacity, I think. Yeah, this is the capacity. I think we don't need all these things. But anyway, we want to search this particular index and we want to insert this particular item on that index. So what we will be doing, we will basically go to that particular index first, okay? And then we insert that element. And we first, what we are doing here is that we just position to the next pointer to that particular index because we want to insert that element in this particular index, right? So we positioned our array one byte next, and then we inserted the element in this particular index. And this is how you have done. So any guesses what is the complexity of order of this particular algorithm?
Big O of n.
Yeah, because we are iterating for n number of times, right? So that's right. Okay. Next, deletion. Deletion also same thing, right? For example, you want to delete, so you iterate and go to that particular element, right? And then in case of deletion, you only have the, let's assume that you don't know the index. Even though if you know the index also, you have to adjust the next bits. For example, let's assume that I have given you delete the element in the 0th index, though it is the first index. But what you need to do, you need to adjust the next elements after that, right? After deleting the second 0th element you deleted, the first element has to be brought into a 0th position. Similarly, the second element has to be brought into a first position, like that. So that adjustment has to be done. For that, you have to again iterate big of n number n minus 1 number of times. So that is n minus 1 is anyway 1 is constant, so you can always ignore. So again, this is a big of n. Even let's assume that you want to delete the last element, right? So last element deletion, we can consider it as a best case, correct? But what is the worst case here? Worst case is the first element deletion. So still we consider it as a big of n, right? Okay. Next, what we have, anyway, we saw insertion, we saw deletion, we looked for searching an algorithm, and whatever we did right search, that considered is unsorted. Let's assume that if it is a sorted, if it is sorted, given an element, you need to search first, right? So what happens when, how you do for sorted element? So basically, I think yesterday we checked this one, right? What we do, we check for the first element, or we go to the middle and check, and then see if that particular element is less or the searchable, whatever element we are searching, whether it is a less or more. Based on that, our search criteria is reduced, right? So either we will be searching in the left, or we will be searching on the right side, correct? So that way, what you are doing, you are in every iteration, you are either you are finding that element, or your search criteria is becoming narrowing, right? So that is the reason, if you have a sorted array, it is big of n log n. And if you want to update the element, for example, if you want to get a certain element, or if you want to get, or if you want to update, right? Set is nothing but an update. So basically it is big of n, because you know the index, so you directly set that particular index or get that particular index, right? So this is common thing. So I think try to remember this, insertion, deletion, search, these are all the very basic things asked by the interviewers. So array, what is the time complexity, if you want to insert an element, or if you want to delete an element, right? So these things are being asked. Okay. Now let's see what kind of questions being asked on the arrays, right? The first is like how you check if array is sorted or not, right? Any guesses? How will you check if array is sorted or not? I think it's
Have a Boolean flag and check each element to the next.
Yeah, basically what we will be doing, we will be checking 0th element with the first element. So 0th element should be less than the array of 0 should be less than the array of 1. Similarly, array of 1 should be less than the array of 2, for example. So like this, right? Array of 0 should be less than array of 1. And this continues, right, till you get array of n. And you started from 0 means it is n minus 1, right? And if I put this one in mathematical formula, right, how it becomes? A of 0, I can represent like this, right? Less than a of 1. Writing on this is horrible, right? And this continues a of 1, a of 2, a of 3, like that, till a of n minus 1.
Firoz, there is a whiteboard option in Zoom meeting. Just try that if that can help you.
Whiteboard.
Yeah. In below options where we see the chat, share screen and all, there it shows whiteboard. I'm not sure if that can help you.
This would be on the Zoom controls, not here.
Yeah, Zoom controls.
This one? But here also I have to write, right?
No, I don't think that one.
Yeah, even the Zoom whiteboard is something like this only, like a free pen.
Oh, okay.
You will still have the same issue.
Okay. Okay, anyway, I think you people got it right, what, how we can check if the array is sorted or not. Basically, I'm trying to compare all the elements one by one. Okay, so this is how you can do something like this. So you start with the 0th element, and then iterate till the nth element. Okay, and then take another for loop, basically, and that you start with the next element. So I'm starting here with the 0th, right? So 0 plus 1 from the next element. And then again, you go till the nth element, right? Here it is less than. So here also less than, because I started from the first element. Okay. And then basically, you just compare with the array of j, the next element with the previous element. If it is, I think I have given the condition otherwise, because I can immediately return false, means it is not sorted, or you continue, right? If the next element is greater than the previous element, so you keep continuing. I think this is n minus 1, I guess, here.
A loop is n-1, right?
This should be n minus 1, yeah, right. And then this is continued. So if you have checked this algorithm here, right? So this is basically big O of n square, because I have two for loops here. Though the next for loop will be like, for example, like let's assume that if the searchable element is at the last, right? So this for loop is also iterating from 0 to n. This is also from 0 to not 1 to n, but still 1 we consider it as a constant. Again, we consider it as big O of n square, right? So in this case, it is big O of n square. To check sorted, we are taking big O of n square, which is not a good algorithm, but this is okay. Solution is available, so you have a solution. But examiner may not be impressed with this solution, because he may be thinking that, okay, maybe some better solution still exists, right? What could you think that what could be a better solution here to check if the element is sorted or not? Instead of iterating, right, we can iterate only one time, right? And then we can check two elements at a time. We can still do that, right? Instead of iterating till n, you iterate till n minus 1 only, right? And then you compare two elements like array of 0 and array of 1. But check that or you start with the 1 here and iterate till n, right? Then you check array of 0 and array of n, array of 1, right? And every time array of I minus 1 and array of I. If I have to say in terms of for loop, right? You are iterating from 1 to n, and what you are checking in the if condition, you are checking array of I minus 1 and then array of I, right? Because you started from 1. So first comparison will be 0 as well as 1. So something like this. I think this mathematical formula I already showed. So we will be going to use something like this. So you started with the I, iterating to n, but you are starting your I from here, first element. So this is what I have done here. So you started from 1 till n, and then what I am doing comparison here is array of I is compared with array of I minus 1, the previous element. At the same thing, same thing here. I am comparing with the minus 1 element. This may throw array out of bound exception in case if you started with the 0th element. So just keep in mind that you need to start with the first element, because the comparison is started just previous to that element, right? And yes, you have to iterate till the n element. So this is pretty sure. So what is happening here? So if you observe, right, with respect to our previous function, this function is much better, right? Because we are not iterating twice. Sorry.
It will take time complexity to big often.
Yes, it takes big of n. That's right. So if you provide this kind of solution, yes, it is better compared to the earlier one. So that also solution only, it works. But examiner will be more interested to judge you how whatever code you have written, right? Even though it is it works, but with respect to time complexity or order of the growth of that particular function, that how it behaves, right? So compared to big of n square, big of n is better. So compared to both the function, right? This function I can say it is it does better. Okay. Okay, let's see the next question. How you reverse an array? Basically, what we need to do, you have an array here like this, right? So you have elements here, something like this. Yeah. So let's assume this is the first element and this is the last element. So reversing means what you will be doing? You will be swapping these two elements, right? These two elements will be swapped. Similarly, what you will be doing, you will be swapping these two elements, right? And then you will be swapping these two elements. Then you will be swapping these two elements. Let's assume that there is one more element here, right? No issues because that is a middle element. There is no need to swap that, correct? So how you can do that? So you can start with the first element, low, consider low as a 0 and high consider n minus 1. So what I will do, I will start from here and n minus 1 means I will be iterating started from 0, right? So it will be like the last element, correct? And what I will be keep checking, I will be checking that this particular condition, when I will be increasing this low and I will be decrementing this high. So I will check one particular point where my low should not cross the high, right? So that I will be checking here. Low should be always less than high. In that case, what I will do, I will keep my low into some temp variable and I will replace the low with the high and high with the low because low was temp right here. And then what I will do, I will increment the low and decrement the high, correct? So with that, what will happen? So this element will go and sit here and this element comes and sits here. Next example, for example, you have an array of 2, 4, right? Okay, let me write here. 2, 4, 6, 7, 9. Okay, these elements are there. In first iteration, what I will do, my low, where is my low? Low is here, right? Where is the high? High minus 1, n minus 1. So this is the high element, right? Started from 0. So what I will do? Array of temp. So I will store low in a temp. So I will store 2 in a temp. And then array of low, I will store it in a high. So this anyway, I stored in a temp variable. And then I replace this with the 9 here, right? So I have 9 here. And then what I will do, array of high equal to temp. So I will put that array of high to here, temp, whatever I stored, right, low. And then in the first iteration, it will be like this, 4, 6, because this I am not changing, 6 and 7, right? And then my low will be now 1, right? 1 is less than high. What was the high earlier? 0, 1, 2, 3, 4, right? Now it becomes 3. So 1 is less than 3. So I will iterate again. So this time what happens, right? My low will be here now. So what I will replace with this for with this while loop. So next iteration, it will be something like this, 4, 7, 9, 7, 6, 4, and then 2, right? And my low and high both are meeting here only now, correct? Because I incremented this, so I decremented. Now low is less than high, no, right? Because it is same. So my condition break. So this is my output array. Okay, what is the complexity here?
Big O of n by 2.
Log n.
Log n. Big O of n by 2 is nothing but big O of n. You mean to say log n? Okay.
Big
By
O of
log
n.
Big O of n. Someone says log n, right? Why log n?
Because you are iterating from both the sides. So efficiently, I mean, basically you are halving the number of iteration.
Yeah, that means big O of n by 2, right?
No, it's log n, right? Basically
No.
dividing it into.
Dividing is different and incrementally dividing is, so for example, like what I can say is like logarithmically I am not dividing, right? You know what is logarithmically dividing, how the log will be computed. For example, this is array. So your search is here. In next iteration, it will be limited for this much only. And in the next iteration, it will become half. So your search will be only this part. In the next iteration, the half, maybe this part. until you find the element. So you see that this is nothing but you started like this and then it is getting into a pyramid shape. But here it is not like that, right? Here basically you are taking big of n by 2, right? If loop is your for loop is of length n, you are always iterating by n by 2 because you are in each iteration you are coming from both the direction, right? So in this case, what is the 5 elements, right? So you iterated almost 2 times, so started almost 3 times, right? So which is nothing but let's assume that even if it has 3 elements, so 6 elements, then it will go for 3 iterations. Correct. So it is n by 2. So we always ignore the leading constant. So we always consider big of n. Is that clear? That log n, whoever said log n, right? So it is basically for him. Okay, moving next. How you remove a duplicate from an sorted array? Here it is a sorted array, okay? So I have something like this. So it is a sorted array, just remember, whenever the examiner asks question, right? Clarify if he asks remove duplicate from an array, clarify whether it is a sorted or not. Even if it is unsorted also, you can remove that. But if it is a sorted, then things becomes much easier, right? So for example, let's consider this case where the array has 7, 7, 10, 10, 10, 20, 20 like this. So you need to remove the duplicate. So you start with the first element and then check that element exists in the next position also. If exists in the next position, then again check for if it is exist in the next position also, until you found that the element doesn't exist. Okay. And then how many number of things you have found, right? You can keep deleting that. For example, here, right, you found 2 elements. First element is there, second element also same case, right? Then you can delete the first element and keep the second element, right? Similarly, when you found that the next element is not the same, what you can do? You can retain this and then come to the next element and again keep doing the same iteration again here as well. Correct? Until if you continue the same logic here, so you will be deleting these 2 items. And in this iteration, you found that the next element is not the same, so you retain the 10. And then keep doing for 20 also. You found that next element is the same, so you delete this. So finally, you have something like this, and 7, 10, 20. Okay. So I think you understood the logic, right? I didn't write the code snippet here, but it is the same whatever I had told. Okay. And what is the time complex? Yeah.
Sorry, one question here. So when you say you are deleting, not related to this sorting and all, but just one question. When you say you are deleting this, are you like, you cannot delete, right? You just replace with some a unique number like 0 or something, or like how you should?
No, delete in the sense like, for example, like if yeah, maybe I confused you guys. When I say remove duplicate from sorted array, right? So maybe you can take a new array and then put all the elements, the common elements into that array, and then finally you can delete that array. One thing you can do, or what you can do is like either this is the possible thing, or you can do is like every time whenever you found the duplicate element, right? You can swap the elements, right? You can keep putting here until you found the last element. So that is also doable, correct? But that was not the question actually. The question was pretty simple one. You need to find that, you need to remove the duplicate from a sorted array. So basically this array becomes this array. So you can, I didn't mention, right? You cannot take a temporary array. You can take a temporary array and then copy the common unique elements into that array, and then you delete this array, or you can rename this array itself as this array, right? That is doable, correct?
But you meant here as when first is compared with second one. So we found it in the second, sorry, at array of first place.
Right.
Then, so we are just sliding the sliding one you are trying to replace. That's it, right?
Correct. Yes, that's right.
Okay.
Yeah. Okay, that sliding thing I will come. Okay.
Yeah.
Okay, so I think you understood how you can remove duplicates, right? Next, you have left rotate an array by 1 space. How will you do a left rotate an array by 1 space? So simple, right? What you can do, you know that you need to rotate in the left. So you have to rotate like this. Rotate in the sense, I have not just said like shift. Rotate in the sense, this has to go and sit at the last now. Okay, so what you do, you take, you store this one in a temp, right? First element, because you are sure that you are rotating by one space. And then you fill up this one, right? You keep shifting this element till you found the last element, right? Last element will be shifted to last -1. And now the first element will come and sit at the last position. This is pretty simple, right? Left rotate by an array by one space, right?
Didn't get it. Can you please tell me one more time?
Okay, so the question here is, you need to write a logic. Okay, given an array, you need to left rotate that by one space. Okay, let me see if I can clean up this. Okay. The question is clear, right?
Yes.
Yeah. So what logic you can apply here? I have to left rotate an array by one space. So what happens is, right? So this 2 has to, this should be the output. The 5 should be moved one position left, right? So 5 will come and sit at the second position, 7 will come and sit at the 5 position, 8 will go here, 9 will go here, and the rotation will happen. So the first element come and sit at the last index. So where the 9 was earlier, so 2 will come and sit here. So you can see 2 here. Now what logic you can apply here? Simple, right? The first element, because I know it is, I'm going to left rotate by one space. First element, I will store it in a temp. Okay, let's assume that is all integer. So I will store it in an int array, int variable. And then I will left shift all the elements by one position left shift. And what you will do, array of 0 equal to array of 1, right? So like that, array of 5 minus 1 or array of 5 equal to array of 5 plus 1, something like that.
We can simply take it like I equal to 1, then like we can make it like increment to till n, and then like what are the temp variable, put in the length of 1, right?
Yeah, you can do that also. Yeah, you can do that also. So finally, you will have array something like this. Correct. So this is simple one, because you know that you are going to rotate by one space. Correct. Now let's assume that that space is not 1. It is more than 1. And this is the logic. So what I will do, I will store it in a temp, the first element, and then I will iterate from the first element till the last element, and the first element will be replaced on the 0th position, right? It is, I'm putting into a previous position here. The 5 will go and sit in the 2, right? So that way, and finally what I will do, the last element will be replaced with the first element. Not replace, actually filled, because we already moved this element here. So it will be filled. So this gap, it is nothing will be there. So it will be filled with this particular element. Okay. Okay. So this is, yeah.
What would be the time complexity of the previous example? Is it of n square or something?
No, big of n only, right?
The
Because
previous,
only for one.
not this one, previous one, the duplicate. Yeah.
Yeah, this is the big of n only, right? Why 2 times? Because I'm just comparing the element. So I told you, right? Let's start with. Okay. So what I will do, let's assume that I have another array, temp array, which I have taken. So I will start with the first element and I will compare with the second element. If I found to be the same, right, then I will make one copy of it. And then my iterate, I will go to the next element, because this anyway, I know I found first element, I will copy, right? Okay, simple one. First element, copy, because anyway, it is unique. Now I will compare this first element with the second element. Okay, 0th element with the first element. Okay, if it is found to be the same, then I will not copy into a temp array. I will move the pointer simply. correct? Now
Mhm.
let's assume that the comparison, I found the new item. So what I will do, my next pointer will be here. So this element I will copy, and I will move this pointer to here. Now my the algorithm starts from here again,
Hmm.
correct? Now this again same thing. So you compare. First you make a copy, compare, again compare. You don't do anything because the elements are same. Again compare. Here you found that the next element. So the pointer, this particular pointer, you moved here. So your algorithm, now the next iteration will start from here, right? So first you make a copy and then do a comparison and keep doing that unless and until you found a new element, and then make that pointer an image. So this is what your array containing unique elements. And now you have removed all the duplicates. Finally, what you can do, you can delete, or you can, point to this particular array. So this will be garbage collected in case of C, or in case of Java. In case of C, you may have to delete that array. Okay.
Since it is sorted, it's fine.
Hmm.
If it's not sorted,
Yeah, in case of not sorted, yes, it will be big of n square, because you have to take two times and you have to
correct.
keep taking the element and deleting. Two for loops you have to iterate. Yeah. So yeah, that is the reason I said, like, first confirm what exactly the question, right? So that you will have a better answer.
Got it.
Or
Thanks.
what happens, like, generally people will they directly try to jump on the solution first rather than, like, understanding. If this particular term is not there, then you can get confirmed from the examiner whether he is interested in a sorted array or not unsorted array. If you say sorted array, then things are pretty simple. You can write a very compact code or simple code. So if it is unsorted, yes, you can anyway, you can write whatever logic you want to apply for two for loops and then do it right. But don't try to do in the first place, correct? And one more important thing here is, right, generally we, as I mentioned, right, examiner will be more interested to see your code where that code is like nicely written, or with a better order of function, right? Big of n, or big of, instead of big of n square, it should be big of n, all that thing. So in a first attempt, right, don't keep all these things in your mind, because what happens, right, if you keep all that things in your mind, then you will be always thinking in that direction. First, try to understand the program logic, how you can use, and then try to refine that logic before getting into writing a code. Try to understand, like, how best you can write. For example, if you use two for loops, then definitely you will have something in mind, right? It will go for big of n square. If you use single for loop, it is big of n. So try to spend some time with your paper and pen and try to understand what could be a better solution. So you will have something in your mind, then you start writing the code, right? This is what common mistake we all will be doing. Spend some time, like 5 to 10 minutes of your time on paper and pen, instead of opening your text editor and started writing the program, right? And then once you are pretty sure, like, okay, I have a solution, but I have another solution which is better than this particular one. If if you are in a dilemma that you are not able to find any better solution, or if there is only one solution exists, then you write only that one. But if you can think with, right, so there could be a better solution, then spend some time and understand that, and then write. Okay, so this is what generally we try to do, right? When question is given, we initially will not understand fully sometimes, then we start writing the code itself, thinking that we understood everything. And let's assume that you read it, he has given remove duplicate from a sorted array, but somehow you missed this, right? Okay, array is given, I have to remove a duplicate. So then you will write a complicated logic, but question itself is much simpler than that, right? So these things happen actually. Okay. So now you
So
understood.
in that case, if it is unsorted, we need to first sort it, then go for the.
You can do that way also, because sorting is sorting is taking big of n time, and then again removing duplicate from that is correct. But let's assume that the question is only remove a duplicate from an array, right? Whether it's sorted or unsorted. But if you remove, let's assume that I have array here 10 is there, right? And here 8 is there. So the final array, how your final array looks like 7, 10, and then somewhere 8 will come and sit here.
Correct.
Okay, but in normal case, but in sorted case, 8 will come and sit here. Correct. So basically, you are actually disturbing the order, right? Here.
Yeah.
Yeah. So keep that one also in mind. You are trying to, yeah, I understood that smartly you are thinking, but that will also lead to some problems later on. So,
But if they have that requirement, like not like 10, sorry, in a sorted return expected one, then we can do it.
Yeah, you can do that. Yes,
okay,
definitely you can do that. But if you compare doing that operator, right, first sorting and then removing duplicate, or removing directly duplicate from an unsorted array, both are leading to big of n square only, right?
Yes, yes. Okay.
Yeah. So that way both are same actually.
Okay.
Right. Yeah. Okay. So I think I explained like left rotating by one space, right? So let's assume that if one is being, okay, it is the same big of n, I think I already mentioned. Let's assume that it is given not only one space, like m spaces. For example, like let's take a simple example here. M is 2, right? So you will be doing the same operation 2 times. So first iteration 2 will go and sit here. In second iteration, second element goes and sits at the last. So this is how it looks like, right? But let's assume that m is more. Let's assume that in this array 5 elements, right? Let's assume that m is given 5. So basically you have to completely, what you have to do?
Rotate 5 times.
Exactly. You have to rotate 5 times. Correct. So basically what you are doing here is like this rotation, right? I didn't write I wrote the code here, right? Yeah. So so it is taking big of n time, correct? Left rotate. And if you're doing 5 times also 5 of big of n. So that doesn't matter. It is big of still big of n, left rotate. Correct? Because you're calling multiple times means that is still fine. So can you think of a solution if examiner asks like this question? This is the kind of questions we face in the exam. So you wrote is fine. You wrote the program, it is good. It is taking big of n time. But can I have a solution where you can reduce this from big of n to big of 1? Is it possible? Okay. What was that question? Reverse, I think we just saw one more example, like where we were like this. Okay, you saw this, right? This, how much it is taking? Big of n, right?
Yeah.
Yeah. Big of n, and then left rotate is big of n. Okay, fine. Okay, so can you think of any other solution where it can be reduced from big of n to, like even lesser than that? Sorry, I think I confused again. So for one space, you will be rotating, you will be doing big of n time, right? For, let's assume that if m space is very large, for example, m is the length of array 5, right? So what you will be doing, you will be in a for loop, you have to write a for loop, right? And then m starts from 1 and then m goes till end, you call left rotate, right? So basically, if you see the complexity of this algorithm, it is not big of n, it is big of n square. Anyone has any doubt on this, why it is not big of n square? Then I will explain. Rotating once, it is taking big of n. But what we are doing, we are rotating, let's assume that full array we are rotating. So you have to call n number of times that rotation. So you will be having another for loop on top of it. So that for loop will take big of n, and this will take big of n. So it is big of n square, one for loop inside another. Any doubt on this? It is taking big of n square. Now the question is, how can you write a solution, left rotate an array by m spaces, where you can have a solution with big of n?
Yeah, there is one way actually
Hmm.
where there will be 3 reversal required. So first reversal will be of the whole array.
Hmm.
Then the second reversal will be of n minus m elements. And then the third reversal will be of m.
Yeah. Right. So this is big of this m, it becomes n, right? It will be big of n square, correct? So basically we can represent it in big of n square only, this one. If in case m becomes large, and if let's assume that m is n only, then it is big of n square. So the worst complexity is big of n square. So this is the possible solution what we did earlier, right? Left rotate for 1 space every time till m. So let's assume that if m is n, so we have big of n square. But so the solution what I don't remember your name because I can't see who was mentioning that. So yes, right. So the same thing we are doing. We are first we are reversing the array, complete array from 0 to m minus 1. How many elements we have to rotate, right? And then in the next iteration, what we are doing, we are again rotating. Not rotating, reversing from that array m with the last element till the last element, right? And then finally we will reverse that one again from 0 to the complete array we will be reversing. I think you find difficult here. Let's take one simple example. So we have 2, 4, 6, 7, 8. Okay. Let's assume m here is 3, right? Let's take 4 only. 4. And what is n? N here is length of the array, right? So we have 5. Correct? So this is, and let's first write what is the expected output, right? What is the expected output here? You will be rotating 4 times, right? So in first rotation, it will be 4, 6, 7, 8, and then 2 will go and sit here. So this is your first rotation. Your second rotation will be 6, 7, 8, 2, 4, right? So this is the second rotation. And your third rotation will be 7, 8, 2, 4, 6. And your fourth rotation will be, it will be 8, 2, 4, 6, 7, right? So this is what you have to do. Basically, you are completely shifting the array, right? Reversing the array. This is how it looks. But it is not actually reversing because 2 is coming and sitting here, right? And 7 is going there. So the final output should be like this. Now, if we apply this particular logic, right? So we have n5, m4, right? So first what you are doing, reversing an array from 0 to m minus 1. So what is m minus 1 here? M minus 1 is 3 elements, right? M minus 1 is 3. So 0, 1, 2, 3. Started from 0 and 3. So what you are doing, you are doing a reverse here. So the first, so this particular one, so what output you will have, right? So you are reversing here. So 7 will come here, 6 here, 4 here, 2 here, and 8 is here. So after this iteration, right, you will have element like this. Okay. So next what you are doing, reversing array m with n minus 1, right? So what is your m? M is 4, right? So 0, 1, 2, 3, 4. So I will have 4 here. And n minus 1. N is 5, the fourth element. So what you are doing, you are replacing the same element with this. So I think with second iteration, this will not change. The example, whatever I took, right, with that, it remains the same. So third, what you are doing, you are basically again reversing, right? Completely you are reversing this time, correct? So how, what will be the output? So 8 will sit here, the 7 will go and sit here, 2 will sit here, 6 will go here, and 4 will come here, correct? And if you see what output we did with mathematical thing, right, with just pen and paper, correct, you got it with your algorithm also, right? So this is what the algorithm does. And now the interesting thing is that the reverse array is taking big of n, correct, and you are calling 3 times, so it is nothing but big of 3n, correct? And applying our logic, right, we always ignore the leading constant, so you can ignore this, so this will be big of n, correct? So this is how it is. You guys understood this, because this is a bit complicated one.
Yeah, Feroz, we understood here.
Yeah.
But when coming from the scratch point of view, for 2, 4, 6, 7, 8, you rotated right 4 times, and the right
Correct.
side you can see. With that rotations, how we can build this logic, this particular logic, reverse array, 3 times, 0 to m minus 1, n minus 1, then 0 to n minus 1. So
Okay.
build, yeah.
You are saying how we can get into this particular logic, right?
Logic, yeah.
See, basically, what exactly we are trying to do? We are trying to rotate, right? Rotate for m times, number of rotations given to us.
Yes.
Basically, for example, this is array 2, 4, 6, 7, 8, right? Now you want to rotate for n number of times. If you rotate n number of times, right? So it is same thing, right? The element is going and sitting next section like that. Okay. So if you sit with pen and paper, right, and analyze that, keep changing the numbers, like change, take a number 2, take a number 3, like that. You can see that basically what we are trying to do, we are trying to reverse an array, okay, multiple times, correct? It is basically swapping the numbers. First, what we do, we swap from, like first to how many spaces we want for m minus 1. Basically, you will be rotating that many number of times. And then you apply the same logic, basically, for the remaining elements. Remaining elements, we are not touching. For example, if I have to rotate 4 times only, but you think that we are not just changing, right? It is like all the elements are coming one position left in every iteration, and the element which are at the leading, right, and going and sitting at the last, correct? It is difficult to explain, but if you sit with pen and paper, and first thing is that the rotation by one space, you understand this logic, how the rotation by one space is working.
Yeah.
And then you understand the logic, how the rotation with the m space is working. And then try to compare, right? One space is very simple one, m space you are doing multiple times. And then now comes next solution, right? And you see this also. In a for loop, you are calling this particular one. Array with n, left rotate, you are calling. But if you see this, how left rotate is working, right, you will come to this particular solution. It is not rocket science, try to understand. If you sit with pen and paper for 10 to 5 minutes, right, you will understand this. If you
Like
want
at
to
each flow,
I can explain again.
Yeah.
Yes, please.
No, I mean to understand, like, when we are reversing at each flow and we are, checking the same time, when we are shifting, into the left position. So that way we'll understand like where it is exactly the digits are getting locating. So that way we can build the logic you're mentioning here.
Exactly, we can build the logic. So if you do 2, 3 times, right, try to take some small numbers for n and m, and then try to do the logic and see how this algorithm is behaving, right? So here is that you have a solution. You have a solution which is taking big of n square. Now the question from the examiner is that, yeah, the solution is good. Well, but I want to see the better solution. I want to use something like big of n or even constant. He may ask, right? Then you can think more on that instead of what you are trying to do here is that you are trying to avoid this particular for loop. But you cannot simply avoid this particular for loop because this left rotation is taking another for loop. So you have to think some different logic, and then you see with the pen and paper how this rotation logic is working. How the shift logic is working, right? So rotation is nothing but this particular shifting, and then that element is going and sitting at the back, right? So this logic, how this logic is working, and whether we can completely avoid this. If you think a bit more, right, you will come to a solution. This particular solution only will come.
Okay.
Yeah, just spend some time because it is not that easy for, like to explain here how I arrived this particular solution. This is the, like there are some better solution, even better than this also you may come up. Okay.
Yeah.
Yeah, so it is only thing is that you may have to sit with some time and try to understand how this algorithm is actually working, and spend some time with your ID or with your pen and paper and try to understand. And then
Correct. Sorry, I don't understand. See, like I just can see the solution. I cannot just mug up it up,
No, you should not be doing that.
Yeah,
You should not be
exactly.
mugging up, because today you will remember, but after 2 months or 3 months, right, you definitely will forget.
Sure.
Correct?
Yeah.
So
Yeah.
see this algorithm, right? You can have a number of ways of writing an algorithm. Correct.
Correct.
Swapping an array, simple thing you take. You can have some totally different solution altogether, and which can be even much better than the standard algorithm, standard things, right? This is how the people have patented this sorting and searching algorithms, right? Correct. This binary search was there, and then there's something called radix. So this sorting, right? There are so many sorting algorithms.
Yeah.
All have different ways of doing that, and some things are best suitable at some certain places. People have used that and they come up with better solutions, and then they propose that solution with their own names, like, right? Merge sort is there, all the different sorts are there, right? So that way they found that, okay, this is the better solution than whatever existing, and they proposed that. This is how this algorithm has come up, right? Yeah.
I have a small question. Now, this reverse array, if it is internally implementing a for loop, right? So it means like we are doing 3 times for loop for each of this line, right? So in fact, it might not be a very efficient one, right? The magnitude is more now.
You mean to say this 3 times we are iterating for a for loop, right? That is still fine, because let's assume that you have a n of 1000 elements and you are rotating for 500 times, right? Now the operation what you are doing here is 3 times big of n, correct?
Yep.
You are going to execute only for 3 times, even your m is 5 and n is 2 less, or even it is very large, right? The number of times you are iterating for loop is 3 times only you are doing, irrespective of the m and n value. Try to understand that when you are solving a question, right, you take a very small number. If you take big number, you will get confused. Take small number and then try to apply your logic for million or billion number of iterations, and then see like how that logic works. And that time only this ignoring the leading constant and ignoring the like lower order terms will come into picture, right? When you have a very large array, when you have millions of records and all, right, so that time it comes into picture. Yeah, but start with the small numbers only. That is better. Okay.
Okay.
Yeah, I think we already have 9:06 now. It is already past 9, and I think I should stop here. Then we'll continue next thing tomorrow. I think we have few more things in arrays to cover. I think this is the last question in array. Okay. Yeah, no, there are a few more questions. Okay. Yeah. So if you are reading this question may confuse you what exactly means the leaders. Let me just explain what exactly mean by leaders here. Leader is nothing but one which is standing in front of it, right? The elements which comes after that should be smaller than the one. The leader means is the bigger one. Okay. So here the leaders in an array, I will cover the logic tomorrow, but what I will explain is who are all the leaders here, right? So 10 is the leader because all the elements which comes after 10 are smaller than this guy. This guy is the bigger. So 10 is a leader. So 7 is not a leader because 8 comes after that. So 8 is a bigger, right? So he's small guy. So we cannot consider him as a leader. 8 also we cannot consider him as a leader because 9 comes after that, which is a bigger one, right? So 8 is also not leader. So ignore 8, 7 is gone, 8 is gone. So when 9 comes, right? So we try to compare with the next elements. So who are all coming after that? So 5 and 3. So yes, 9 is bigger than that. So 9 is also a leader, correct? Then we move to 5. We check what comes after 5 if it's any bigger element is there. No, right? 3 is the smaller one. So 5 is also a leader. So why 3 is a leader here? Because anyway, 3 exists and there are no elements after that, which is more than that. So logic is simple. So 3 is also leader. So we'll try to see how you can implement and what is the time complexity for implementing this algorithm tomorrow. Okay. Meanwhile, if you have any questions, you can keep them with you and we'll discuss tomorrow. Yeah, I think we will, I don't think we can complete this session. So, keeping our portion so much and we are still in the arrays only. There are so many things to cover and we have only 2 days left, and then Saturday we have a one-on-one session. Okay, let's see like if there are any other possibility we can continue this session and it can be beneficial for the people who are looking for jobs, right? Yeah. Okay, yeah, that's it from my side. Souvik or Satish, if you are there, then I would like to stop share and then you can take a control. And let me just stop the recording here.